The relentless reason your blood rises and falls on the same 12-hour rhythm as the ocean isn't poetry. It's a warning your body still carries, but stopped listening to. Somewhere on this planet, that same lunar pull grows so violent it can force a river to run backward. In 1869, in Nova Scotia's Bay of Fundy, the water rose 19 feet in a single night, drowned dyked farmland that had held for 200 years, and swallowed entire villages before the sun came up. Here's what almost nobody outside that coastline understands. The Bay of Fundy doesn't just have tides. It has the highest tides on Earth, up to 53 feet, a 4-story building of ocean, rising and falling twice a day, every day, forever. That's over 160 billion tons of water moving in and out of one bay, more water than every river on the planet combined. If you stood on the mudflats at low tide, you'd have less time than a lunch break before the water reclaimed the ground beneath your feet. And the reason it happens at all sits on a knife's edge so precise that scientists still can't fully explain why it hasn't broken. Here's the first thing they did figure out. Every bay of water has a natural rhythm, a rocking motion, like water sloshing in a bathtub. Push the tub wall at just the right moment, and the water climbs higher with every push. The Bay of Fundy's natural rocking period is close to 13 hours. The moon's pull on this stretch of ocean arrives every 12 hours and 25 minutes. Those two numbers are almost, not exactly, almost the same. Every incoming tide arrives just before the water finishes falling from the last one, stacking motion on motion, doubling the swing again and again until an ordinary tide becomes a wall of water strong enough to erase a coastline. It's called resonance, and it is not stable. It is not guaranteed. It is a coincidence of geography so fragile that if the bay were even a few miles longer or shorter, this wouldn't happen here at all. Then there's the part that isn't in the textbooks. Drive to St. John, New Brunswick, and you can watch the St. John River run backward. Twice a day, the incoming tide overpowers the river's own current so completely that the water reverses direction, climbing upstream past a set of underwater rapids locals still call the reversing falls. It's real, it's documented, and it's only the visible half of something bigger because the resonance driving it isn't fixed. It shifts with sea level, with silt, with the shape of the seafloor itself, which means the tuning that built these tides could already be changing beneath the surface, and no one would see it happen until the water arrived somewhere it never had before. That's what makes 1869 so unsettling. The Saxby Gale wasn't just a storm. It struck at the exact peak of an extreme lunar tide, the resonance already primed to its maximum swing, and the storm surge rode in on top of it. 19 feet of water in hours. Dikes that Acadian settlers had engineered generations earlier, walls that had never failed, dissolved in a single tide. Hundreds of livestock drowned, farms vanished, and for decades afterward, fishermen and surveyors reported something stranger still, stretches of the bay where the tide seemed to hesitate, pause, then reverse early, arriving and retreating out of rhythm with the charts. Some blamed shifting sandbars. Some blamed the 1929 earthquake off the Grand Banks, whose tsunami waves reached these very shores and may have quietly reshaped the seafloor's depth. The one variable resonance depends on most. Nobody has ever proven which explanation is right. The tide tables still work mostly. But every engineer who studies Fundy admits the same thing off the record. The system is balanced on a coincidence, and coincidences don't announce when they end. Which is why this bay is both a warning and a resource nobody fully controls. Engineers have spent decades trying to harness Fundy's resonance for tidal power, machines that could feed electricity to an entire province from water alone. But the same forces that make it a power source make it unpredictable. Sea level rise is already measurably altering how far the tide climbs each decade, and altering resonance means altering everything downstream of it, literally. Coastal towns built for a 53-foot tide were not built for 56 or 60. And the same 12-hour pull tugging at this bay is tugging at the fluid in your own body right now, on a rhythm you never chose and can't turn off. So here's the question nobody in Nova Scotia likes to answer directly. If the resonance has already drifted once, quietly, unnoticed, until a storm exposed it in one catastrophic night, what happens the next time the moon, the tide, and the shifting seafloor all line up again, and nobody's watching the numbers closely enough to see it coming until the water's already inside the dike?